All right. So this is going to be 3-2 logistic equations and a couple things. You can look at the ebook. They give you a bunch of different wordings and how they go from it. But the main thing is what you want to do is get an equation for your differential that looks similar to the dP over dt, P being population, and A and B are going to help us set up our solution here. So now you could go through and separate and integrate to get from here to here, and the book kind of goes through that for you. But really what we're going to do is, if you could remember this, right, I'm going to show you how to use this equation P of t to help us. A couple things that you want to use. All right, K is the carrying capacity, so if there's a limit on what is going on in the situation, you'll see when we have this next problem. Our carrying capacity is really just the amount that will bring us to zero. So maybe it's a little confusing now, but you'll see as we go along. All right, so this is what I want to use today. I'm going to try to get a differential in this form, and then I'm going to use that form to try to figure out, well, what is A and what is B. P naught is still, your initial value. All right, so here we have this question, which it's funny that the book has this question in there, and we're dealing with a similar situation in real life. So one student, a student carrying a flu virus, returns to an isolated college of 1,000. So here, when you look at one student carrying the flu, that's your initial value. X of 0 equals 1. And right here, this 1,000 is your carrying capacity, meaning that eventually everybody will get the flu, okay? Hopefully not in real life. And again, with the way it's written, all right, there's a rate. Rate is derivative is spread proportionally, not only to X, the number of infected, but also to the number of not infected. So when you're setting up that differential, I'm going to use the same variable X. So dx dt equals, you're going to always have that K, X, number of students infected. Since there's 1,000 students on campus, that means 1,000 minus X would be the number of students not infected. So infected students, not infected. Okay. Now what I want to compare, I want to compare this equation, right, with this equation up top, because I want to figure out what my A and B are going to be. So let's put them side by side, right? We could do this. Let's see if it grabs the whole thing, yeah. Bring it down. All right, so you could see here that, like, when you're looking at what is A going to be, you have this 1,000, but you don't have the K. Remember, you can multiply through that K. So A is going to be 1,000 K. B is just going to be K. Okay, and I just got that from this equation here. Now, we could delete this. Okay, so now we know what A and B are, and now what I want to do is use that equation and plug everything in. The only other thing that we would need is, what is our P naught, right? So our P naught is going to be 1, because that's the initial value. There is one student infected with the virus. All right. Okay, so then from here, let's look at that and let's set up our equation. So I have X of t is going to equal A, which is that 1,000 times K times P naught, which is 1. P is K, P naught is 1, plus A is 1,000, K minus B, which is K, and then P naught is 1. And then you have this E raised to the negative AT. So negative 1,000 K times T. So two things I'm going to do. We could rewrite this 1,000K minus K as 999K. Also, I'm going to divide out all the K's. Okay, so you have this equation here that we want to use, and that's how you could use what formulas are given to you, okay? Now, we still have to find what K is going to equal. So in order to do that, right, we want to use what's given. So I want to use the 4th day, there was 50 students infected, okay? So let's solve. So you have 50 equals 1,000, 1 plus 999, e to the negative 1,000, k times 4. Okay, so we need to solve for k. So let's multiply by the denominator here. So I get 50 plus the 999 times 50, e to the negative 1,000 k times 4 equals 1,000. So we'll have 999 times 50 e to the negative 1,000 k times 4 equals that 950 if I subtract. If I subtract the 50 to both sides, and it would look like that. Okay, now from here, right, from here, we could say, you know, just by simplifying, you're going to divide, you'll get e to the negative 1,000 k times 4 equals 950 over this 999 times 50, right? Notice I'm not really simplifying. I'll do that now with the calculator. And e to the negative 1,000 k times 4 equals, this will be 19 over 999. All right, if you simplify. And what we could do now is do ln to both sides. And if you notice, I still haven't multiplied by 4, even though you can, right? And now I want to divide both sides by 4. So the reason why I am writing it this way is if I do this, I could get and just plug in for that 1,000K that I had initially. You don't have to do that, but it's just something that I like doing so I don't have so many numbers there. You know what I mean? It's just too many numbers with these decimals that we're going to have. So now what I could do is plug in for 1,000K this number, okay? And now I have, like, if I go back up to my equation, now I could just plug in for 1,000K. So now my equation that I can use will be x of t equal to 1,000 over 1 plus 999 e to that number that we got, negative 0.9906 t. And now I could use that to figure out, well, how many students would be affected, right? So I'm just really plugging in t to be 6, and just watch when you plug into the calculator that you're doing correct order of operations, and if I plug in 6, right, I get approximately 276 students. Okay. So that's the first example that we have here. And again, the main thing when you're doing these is like what I did in the first step, is try to just compare your values that you have, and then you'll be able to set up your equation here. Okay. Now the next one that I want to do is going to be second order chemical reaction. All right, let me just get some notes. Okay, so what we have now is a different type of notation here that you want to use, right, for the chemical reaction. So this is always like you have a compound that is formed by two other chemicals. And really you're just putting two things together to form another thing, basically. So two, like if you look here, right, chemical C is formed by A and B. So you're taking two things, making a new thing, right? And when you're doing these, you're going to want to use this notation here, dx dt, equal to, again, some variable k, and then it's A. Actually, it's not A. They like to write it as alpha. So alpha, right, minus x, and then beta minus x, like that. Okay, a couple of things here that you would like to figure out is what is alpha. So alpha is going to be, they give you this notation in the book, and I'll explain what this means. And beta is this notation. Okay, and with that, so a couple things. What is A? A is the amount of chemical A. B is the amount of chemical B. M is the, so the parts of, let's say, A that make the new compound, and in our case C, and N will it be the parts of B that make C. Okay, so really I'm trying to give you guys some easy ways to set these things up, right? So these are probably what you want to use when you're trying to do this, so that when we go into the problem now, we could kind of get these values. All right, so let's just see what we got here, right? So you know that this chemical C is going to be made up of A and B, and as we read along, it says the two chemicals such that 1 gram of A and 4 grams of B is used, right, to make 1 gram of C. Okay, well, not 1 gram, 5 grams of C. So what we'll have here is, really, if you think about this, parts, right? So parts that you have, that's where you have the M plus N. So in our case here, alpha is just going to be, M is going to be 1 plus 4, and then we're dividing by M, which is 1. All right, so I know I don't have that A there yet. I'm going to put that in a second. B is going to be 1 plus 4 divided by 4. Okay? Now, as you read along, there's 30 grams of component C is formed in 10 minutes. We're going to use that later. Okay? So 30 grams. So X of 10 is going to be 30. And then here, determine the amount of C at time t, the rate of the reaction is proportional to the amount of A and B remaining if initially there are 50 grams of A, right? So there's your A, 50 grams, and 32 grams of B. 32. So here we could see that this is just going to be 250, right? And this is going to be 40. So now we could set up this equation where we're going to have dx over dt equal to k, and then you have 250 minus x and 40 minus x as well. Okay. The other thing that I want to use here, all right, the other thing that I'm looking to use here is, well, how much is initially started? Well, there's none. Okay, x of 0 is going to be 0 because we didn't do anything yet. We didn't start the chemical reaction yet. So right now we're all set up. So that's how you set these problems up. I mean, as best you can, you want to try to set it up that way. And now we could go ahead and solve. All right, let's show you how to solve. So again, I'm going to separate and integrate, right? So I have dx over 250 minus x, 40 minus x equals k dt. Again, we're going to have to do partial fractions, so I'll have 1 over 250 minus x times 40 minus x equal to a over 250 minus x plus b over 40 minus x. So I'll get 1 equals a times 40 minus x plus b times 250 minus x. If x is 40, then b is going to equal 1 over 210. If x is 250, then b and a is going to give you negative 1 over 210. Alrighty. Now let's use those values over here. So I'm going to do the integral. A was that negative 1 over 210. And then I got 250 minus x. And plus 1 over 210 and 40 minus x dx equals the integral of k dt. So let's kick out the not the negative, just the 1 over 210. And it's going to give me ln. So just be careful here, right? So, right, you see that negative, so it makes that a positive 250 minus x. And then this is going to be a negative, and it's minus ln of 40 minus x equals kt plus c. Okay, now we could solve. So if I multiply everything by 210, and let's just put these two things together, 250 minus x over 40 minus x equals 210 kt plus c. Remember, c is still going to stay constant. So you have 250, all right, minus x over 40 minus x equal to c e to the 210 kt. Alrighty. Now, we could solve for c here because we do know our initial value is 0, right? So use the initial value, x of 0 is 0. So if I plug in, I get 250 over 40 equals that c value that I got, okay? So we could plug that in. Okay, so I have that set up there. And now we could use the next thing that was given, right? What was given earlier? After 10 minutes, it's 30, right? 10 minutes, you get 30. So remember, in this situation, this is t, and this is x, okay? So that's gonna give me 220, right? 220 over 10, right? Which we could simplify to just 22. And then here you're going to have e to the 210k times 30. Times 10, sorry. So we could do a couple things. Like if you eliminate these zeros, right, you have something that's a little nicer. So we'll have 88 over 25 is equal to e to the 210k times 10, right? If we do ln to both sides, and I'm doing the same thing where now I'm going to just divide by 10, right? Divide this by 10, so that way I get 210k equal to, now this I have to put in the calculator, I get 0.1258, and now I could rewrite my equation if I plug everything in, right? So let's see. So I'll have 250 minus x over 40 minus x equal to 25 over 4 25 over 4, sorry about that, and then e raised to the, what was it, 0.1258 t. Okay. All right, solving this now. So what you're going to want to do is distribute, right? So if you distribute, you get 1,000 minus 4x over 1,000 minus 25x. I forgot my e. Okay, so that one is good. All right, 1,000 minus 4x, and then here don't forget the e, so 1,000 e to the 0.1258 t minus 25x e to the 1.1258 t. What am I doing? Sorry guys, that's not how you cross multiply. So I'll do that again. 1,000 minus 4x equals 1,000 e to the 0.1258t, and then minus 25x e to the 0.1258 t. Bring your x's together, right? So I'm gonna have 25 x e to this 0.1258 t minus 4x equal to, now bring the 1,000 over, so I'm just rearranging. Okay, factor out the x. I'm going to factor out this 1,000 just so I don't have to write it over and over again. And then divide. So I'll have x of t equal to 1,000 e to the 0.125 t minus 1 over 25 e to the 0.1258 t minus 4. Okay. Now, let's go back up to see what the question was, right? Let's go back up to see what they're asking. Okay, so here they say, after you do all this work, I know it's a lot. This is class you signed up for, right? So they say how much of C is present at 15 minutes. So that's the easy one, right? Just be careful of how you're substituting in. So x of 15 winds up being, where did I put my answer? So you have approximately 34.78 grams, right? So that's the first part. And then the second part, they're asking, as t goes to infinity, right, as time goes on and on and on, does this, you know, plateau, meaning does it flatten out, where it's only going to make you so much of that component C, or compound C. So if you do that, really what you're doing is you're taking the limit as t goes to infinity of our function x of t. So now let me go over this a little bit. If you go back to like Calc 1, I believe it is, right? Your degrees are the same, right? You have the same number here, okay? And if your degrees are the same, if you remember from Calc 1, then you just take the leading coefficient. So it's going to be 1,000 over 25, which is 40. So that's how much over the course of time, when you're mixing these two together, right, when you're mixing these two together, this is how much of component C is formed. Did they ask anything else? Oh, okay, so that's it. All right, thank you. Sorry about all the noise.